All right. So here we are on the 17th of November. And tonight we don't have any planned new material. Okay. It's really just being here to work on things, get any questions answered that you might have. I can do additional demos of any of the homework or whatever you need. All right. Or it's just independent work time. Totally up to you. Next week, Monday on the 20th, we will have a lecture at that time. I do have some planned things that I want to make sure that we go over, but the 22nd will be a day like today, totally optional. I'll be available. I think I'm going to make that one virtual, just because it's that Wednesday before Thanksgiving and, that kind of thing. So if you did want to pop in virtually, you certainly may, but again, no new information. It's just a virtual lab, no lecture. Okay. And then we're obviously off on Friday, and then it's back to our regular schedule again. Okay. Let me see here. I've got an assignment. Oh yeah. I've got assignment number 5. I'm trying to think. How come I feel like, number 5, I think is gears. I think that's coming later. So I think I just have that out there. Don't worry about that due date at this time. So are there any questions calendar wise? All right. So really what you're working on right now, the acceleration stuff is, probably top of mind. And if you have any questions on that tonight, I do want to talk to you guys about one of the problems that we did the other night. We discovered a problem with a final answer, and it's, when you see it, you'll be like, oh yeah, okay, that makes sense. So I have to pull up my my camera here and go underneath. And the problem I'm referring to is 738. I think it was the last problem that we did. We did 2 problems that night, like top to bottom, start to finish, and they were 2 of your homework problems, really kind of looking at, one was a slider crank, and then one was a slider rocker, or I'm sorry, a crank rocker. And the crank rocker is the one that at the very, very end, the whole process was perfect. All was good, except here. We ended up, I know that I led you guys. I said 4.457 radians per second squared was the final answer, but actually it was supposed to be 44. And that was based on the factor that we were using when we did our drawing of our vectors on the diagram in AutoCAD. So that was my fault at the end, and nobody really caught it until I think it was later in the evening. One of the students was catching up on things and was wondering why I had, he had 44 and I had 4. And then when we looked at it, I realized that I didn't divide by the correct factor that we had scaled the vectors to. So please just update that, and then 44.56 or 44 or something right around there, depending on your your rounding. It might be a little bit different. Okay. If you do notice that your numbers are a little bit off because of that, truly assume that it is rounding, especially in the book, because they carry everything just to 3 significant digits and then use those to multiply through the problem. And when we have problems like this where there so many different steps and you're using numbers, and we have the ability to have accuracy to 4, 5, 6, 7 decimal places, even off of CAD. We end up using them, and it's always good practice to use your numbers throughout and then round your final answer rather than rounding early on, because that can make a difference. So just kind of know, as long as you're like right in the numbers, you should be totally fine, and it's probably just a rounding thing. So other than that, then as we look back at our homework that we have assigned, and when we look here at assignment number 4, the first problems here through number 18, these are the general acceleration ones that you don't need any AutoCAD or diagrams for. But then when you start with 26, 34, 38, and 44, those last 4 do need to use the AutoCAD with the relative acceleration method. So graphically doing those. The 2 that we did on our first evening, or last time that we were together, was 26 and 38. Okay, so 34 is very similar A little bit, it's a different diagram, but it's a slider crank. So process wise, the same as 26. And then 42 is, again, that one is a small aircraft landing gear, but it's a crank rocker mechanism. So it again is going to be similar to 38. Okay. So at this time, does anybody, anticipate do they want me to do any demos, or do you feel like based on what we had done last time, you can work independently? And any needs that you have like right now? Crickets. That's okay. That's okay. And that's, you know what, I'm happy that if you are confident working, go ahead and work independently. All right. But then if you do have any struggles as you go along, that's what I'm here for. Okay. So whether you're virtual and you want to just kind of hang out and do homework and then have me available to answer questions, or if you wanted to work another time independently, that's totally up to you. All right. So I'll let you use this time as you wish. So then what I'll do is I'll kind of stop this. I'm going to stop, not kind of stop. I'll stop this introduction, and then I'll be back if anybody has any requests for any demonstrations.